are going to use an exponential model to figure out the forest fires and if a fire department will need to call for extra reinforcements. So the diagram shows how a forest fire grows over time. The fire department can contain a 160-acre fire without needing additional resources. About how many minutes does it take for a fire to become too big for the fire department to contain without additional resources? And then we need to round to the nearest minute. So we've seen a lot of forest fires in our own country and other countries, and we've seen that a lot of fire departments do need reinforcements. So let's see how long it takes, and notice how it says how many minutes. It's not hours or days. We're looking at minutes of this burn. So first we need to find the ratio of the burn so that we can find the base of our exponential function. So I'm going to take 7.2 and I'm just going to divide it by 4. And I get 1.8. That's the ratio between minute 0 and minute 1. Let me see if that holds true. 12.96 divided by 7.2. And I also get about 1.8. So 12.96 divided by 7.2, I get 1.8. All right, keep testing this ratio. Because remember, we're looking for a rate, so we have to find a ratio because rate is derived from ratio. 12.96, and we get 23.3 divided by 12.96, roughly about 1.8. So now I can say that my base or my ratio is 1.8. All right, I know that my exponential function follows y equals ab to the power of t, so we know what b is, so we now have y equals a 1.8 to the t power. All right, the initial amount of acreage that initially burns is 4. That's what A is going to be. A is going to be that 4, that initial amount that burnt at time equals 0. So now we have y equals 4 times 1.8 to the t power. All right, so now the model is going to be, we know at 160-acre fire, which is y, 160 acres, is the moment that the fire department can no longer contain the fire and needs additional resources. So I'm going to substitute 160 for y equals 4, the initial 4 acres, times the rate at which it's burning to the power of t. And I have to solve for t, and since t is an exponent, I cannot just divide this out. I actually cannot multiply 4 in either. This is the person and their little arm is out. We're not going to multiply this in and disrupt this t hanging out here. So what I'm going to do is I'm going to log both sides. Log of 160 equals log of 4. Actually, you know what? I lied. I'm going to divide that 4 out right away. So I'm going to divide by 4. Make this a little bit easier on myself. 4 goes into 16 4 times. That's 0 equals 1.8 t. Now I'm going to log both sides. So I have log of 40 equals a log of 1.8 t. And then using the power property, move that t out. So I get log of 40 now equals t log of 1.8. Isolate t by dividing by log of 1.8. And I now can use my calculator, substitute these in, or plug them in, and then I get t is approximately 6.276. So about 6 hours is when they probably should call for reinforcements. Or even 6 hours, 6 minutes they should call for reinforcements. So if they don't have the fire contained within 6 minutes, they will have to require additional resources. That is hardly any time. I'm not quite sure how long this video is going, but it's probably the amount of time this video has gone on for. So for me to calculate this amount is the time when the fire department would need to call in for reinforcements for this forest fire. Alright guys, so this is the use of an exponential model. If you have any questions or comments, please feel free to contact me, and I will see you in the next video.